how to do a chi-square test and then chi-square analysis. It's a very simple thing, but it's important to also look at the process. So first of all, I have chi-square test is used to do basically two things. It's just to test what is it in what independence or association and then goodness of fit. So you want to find out whether what is it, the occurrence of something is associated with another thing. Okay, let's say the probability of buying maybe a particular dress is associated with gender, or the possibility of going out is associated with gender, and all of that. So anytime you want to associate one variable to the other, the only way to do that is to do a chi-square test to find out whether is there any association between bacteria species and then the resistant pattern, whether it is resistant or it is susceptible. So chi-square test is what we use to be able to do that. And so how do we conduct the chi-square test? That's what I'm going to what to take you through. Now let's look at this. So okay, so maybe I should read the whole thing that you see here. Or yeah, let me explain before. So we have the species here, E. coli, Klebsiella pneumonia. And then we also have the resistance here. We looked at in E. coli, we've recorded about 40 resistance, then 20 susceptibility. Klebsiella pneumonia 20, and then 10 in that order. So we come here, and this is what we have observed. So what is the what is the expectant or the expected resistance and then the expected susceptibility? So we need to calculate that, and then we can then go ahead with our chi-square analysis, and then finally our p-value calculation, which is here. Now, I want us to pay attention how to be able to calculate the expected, and then how to calculate the chi-square, and then how to calculate the p-value. So in order to do that, I'm just going to delete the whole thing here, and then let's start all over again. So obviously too, this one you will not have it. This is how the data would have appeared. I'm also going to come here, delete all of this. Then, so when you have a data like this, let me also take this out. The first thing you need to do is to copy your data, copy this, and then maybe shift to this place and paste it. No, yeah, and paste it here. And after you have done that, so we delete these values which are there. Pay attention critically. There is a reason. Now we are going to rename this variable as expected. So E underscore resistant, that's so we also will put over there expected. And so here, this will be our observed. This is our observed. So we'll leave those ones the way they are. That's our observed and then expected. Now, the first thing to do is to calculate the totals. And like I told you, now, if you want to calculate the totals, that's the row totals and column totals, highlight and then add one more, and then also add some rows down there. And now press your alternate key down and say equal. It will simply that's your total over there. And this place too is also your total. We actually don't need it that much. Now we calculate our expected. The expected is always equal to the row total times the raw. So this is our overall. So let's highlight it. Okay. So if I come here, this is the observed value. This is the corresponding expected value. So the expected value, I will come there and say it, I said, is equal to the row total. What's the row total? Is 60. You see? Then multiply by the column total, which is it is found in that column, which is 70, all divided by, so I'm going to close it, best practice, all divided by the grand total here. But before I can say anything, so okay, let me also close this side. So, but before I will tap my enter key, there are a few things we need to lock up here. So if I come to this place too, it's going to be this, you see, it's going to be this particular row, or sorry, yeah, this row total, still multiply by the 70, by this column total. It means column is fixed, what the grand total is also fixed. So we'll fix those ones. The column total is B4. So I'll come and put my cursor here and say the function key and F4 on my computer to fix it. If you don't know how to do it manually, just put $sign where, and then this is the grand total, which is now also shifting. So we have to also fix that one too. Oh, sorry, it's F4. And so we fix it. So now we tap enter. That way we can now drag, and then it will calculate the next one, the next expected. When we come here too, then we are going to say the same thing. We open our bracket and say we are looking for the observed. So the observed susceptibility is this one. Multiply, no, sorry. That's, we are looking for the row total of that particular. So this is the row total. So it's here. Then multiply by, this is the column total. Then I'll close my bracket and then divide by the grand total. As usual, the column total is supposed to be fixed, and then the grand total is also supposed to be fixed because those ones are not shifting. Then I'll tap enter and I'll get my, then I'll simply fill them up. We have our observed values and then we have our expected values. So maybe the observed values, let me change their color to, let's say, red, and then leave the expected values. Okay, let me also change that one to, let's say, blue. So now, when we have the whole of this, what is left is for us to calculate our chi-square. So the chi-square is always calculated as the observed minus the expected all squared divided by the expected. This is what I mean. So we are going to come here, or we are going to come to this column and say our chi-square calculation. This is our chi-square, what is it? Calculation. So we come to this point, and then we are going to start with the first one here. So we say is equal to, so open your bracket and say the observed. So this is, what is the observed resistance? Is this value here minus the expected. This is the corresponding expected. So I'll close the bracket up and say all raised to the power 2 divided by the same expected here. All right. So if everything is fine, we should tap on our enter key and should be able to calculate. Now let's see. If I tap on my enter key, then he does the calculation for me straight away. Now, if I come here too, it's going to be the same thing. It's going to be this particular value minus this value. So it's going to be this minus this, and then also, okay, everything, I mean, raised to the power 2, that's squared, divided by the same value here. So instead of, because all of them are going to shift, I can simply just drag this here. And you see, it calculates the second value. Now come and look at the formula. It's B3 minus G3. Where is B3? B3 is here. You see, G3 is where? This one. And then come to look at the, what is it? The division is the same thing. So when we come here, we have G3 minus B3 minus G3 all divided by G3, and then we can see it. So that's why we have it over here. So let's try and see if we can also drag it across here. So it calculates that value too as well. Now let's look at the formula. It's C2 minus H2. Now, in that case, we are calculating, we are comparing this value here, this one here, and then this one here. So this is our observed, which is C2. This is our expected H2. So now come and look at this. Is C2 minus H2 all to the power of 2, all divided by H2, and that is okay. So we drag it across here, and it's still the same thing. So when I come here, you see it's now C3 minus H3 all divided by H3. So now we've calculated we have gotten all the chi-square values. But the chi-square values is the sum of all that I have done, if you look at the formula. So we need to now sum everything, you see. So to sum everything, we simply just say equal to sum, we use the sum value, and then just highlight the whole of this, close it, and return. And then this becomes our chi-square value. So this is now our chi-square value. That's our square value. Now, if this is our chi-square value, so what is the p-value? Because that's what we are going to use to be able to determine whatever. Our p-value will now be equal to, we can now use the function, we can now use the chi-square distribution here. All right. And so you see that it's asking us for a particular value and then a degree of freedom. So the degree of freedom here, because it is a 2 by 2 table, the degree of freedom is 1, because it is rows, number of rows minus 1 times number of columns minus 1. So 2 minus 1 is 1. Columns 2 minus 1 is 1. 1 times 1 is 1. That's what we have. So when we come here, we are looking for our chi-square distribution, right? So we are picking this particular value. And then our degree of freedom is actually 1. So we close it up and then tap enter. Then it should be able to give us 0.3 order. Now, there is another straight way of calculating the p-value when you are dealing with it. So that is chi-square dot. So we're going to have chi-square dot test, which is, so we can use that one, but with that one, the actual range and the expected range. The actual range is where we have in red here. Over there, range is where we have blue. To be able to give us the p-value, and you see that the p-values are the same. But the reason why we went through to calculate the chi-square was to get the chi-square value. If we use the second approach here, you only get the p-value, but you won't have the chi-square value. But in any other case, is the p-value that we are looking for. And then here, the p-value is 0. And you know that is way, greater than 0.05. Reject the null hypothesis, whichever was the null hypothesis. Once this p-value is greater than 0.05, we have to reject the null hypothesis. So we can say maybe it's either if our null hypothesis was that there is an association between a species and then the resistant type, then we can reject it. If we say there was no association, then we can fail to reject it. Then about your null hypothesis was all about. But this is how chi-square has been calculated. This now, another one is here. You can try this for yourself. But like I said, the easiest way to always do it is just copy the whole of this. All right. And then simply come and then paste it just here. Now remove the whole of these values, because those are now going to be your expected. So when you come, you can now simply highlight and then leave one more rows. Use your alternate key, and then it will give you the totals. And so this becomes your totals. And then now you can come here and now you have your overall total, which is here. So I'm highlighting again in this. So now when I come and I want to calculate the expected value has to correspond here for CTX carriages, then we have here. Now, when I come to this place, how do I calculate the expected value here? I have to look for the row totals, multiply by the column totals, divided by the overall total. The overall total is 90. So if I come here, it's going to be the row total. So I'll open my bracket. I have my row totals, multiply by the column total, which is here. You see, then bracket close, then divided by the ground total. All right. But like I said, as usual, the, the ground total and that of the column total are always fixed because they don't shift. So you simply put your cursor there and then say function and F4. Then also come here, press your function key and press F4 to fix those cells. Then tap enter. Then that should be able to, and now when you run through, you should be able to calculate the rest. And that is to be expected because all of them are 30, 30, 30. And this one too is also 53. So it's the same thing. That's why the value is here is the same. Maybe we should reduce it to some few decimal places. And then we come here, this place too, we are saying that we have to calculate our expected. As usual, is the row total multiplied by the column total here. Then we close the bracket up and then say divided by the overall total, which is here. As usual, fix these cells, the column total and the ground total. So you press your function key down and F4 to fix it. And then also come here, press your function key down and F4 to fix it. And then tap enter. Then that should give you your expected values. And then as usual, let us reduce the decimal places to 1. And then that is it. So now if we have our observed and then our expected, we can now calculate our chi-square. Then at the chi-square, we need to be able to do that at once. So I'm just going to come here and say my chi-square is, open my bracket, and I will say it is the observed minus the bracket close and 6. That's give you square raised to the power 2 all divided by expected value here. At this point, none of the cells are supposed to be fixed. So I'll just tap enter. And in that case, I'm supposed to move 2 more rows to calculate for this and for that. So I'll simply just come here. I say 1 and 2. It will calculate it. Then I'll also move to the other side. It will calculate it automatically. And then let me just reduce the font size. And so that's my chi-square table here. The actual chi-square value. Then I can simply just come here and say use the sum function, and then just highlight the whole thing here, close it up, and tap enter. That will give you, this is your chi-square value. That's my chi-square value. So what will be my p-value? The p-value is always the most important. So this is the chi-square. Okay, oh, sorry. So let me label here. That's the chi-square value. And then the p-value here. Then the p-value, we now use the function. We have chi-square distribution dot right, which is here. And then it's going to ask me my chi-square value, which is here. And then, of course, it also asks me of degree of freedom. Remember, degree of freedom is always, as we calculate the degree of freedom as well for us to see. The degree of freedom, if I enter right now, I'm going to get wrong figure. So just relax. So that when I calculate the degree of freedom, the number error because there's nothing inside there. So degree of freedom is always equal to the number of rows minus 1. So how many rows do we have? 3. 3 minus 1. So it's going to be 2 multiplied by how many columns do we have? There are 2. 1 and 2. Then 2 minus 1 is 1. So my answer is 1. So if I tap return, it should go and check my p-value. The p-value is actually 0.000. If I come and raise the so you will see this is the actual p-value. Is 4. So wait, first, in order samples. And then when you collected, this was ECU clinical susceptible. And then in some places, ECB. So you want to find out whether this is the source of isolation. This is the activity pattern. Now, is there a association between the source of isolation of the bacteria and then the way the bacteria react, whether it is resistant or it is susceptible? You see, this is how the data will come. So when you see something like this, the first thing for you to know is to know how many variables are hidden inside here. So first of all, you need to highlight everything here. Then go to your data tab here and then come and click filter. Come and click filter here. Then it will give you the double filters. Now filter this and then you notice that how many variables do you have? There are 3. CTR carriage, ECBU clinical, and ERT carriage. That kind of 3 variable that you want to find out. Those are the source. So there are 3 isolated. Come to this side and you notice you have only 2 variables, resistance and susceptibility. So now you will come and create a new more table and say source of isolation, and then you have susceptibility, and then in that order. So now when we come here, and then CTR carriage, then we have ERT carriage. Then we have ECBU clinical. Clinical. Now, we have to now count under the CTR carriage, how many of them are resistance? How many of them are susceptible? Now, the ERT carriage, how many are resistance? How many are susceptible? Then the ECBU resistance, and then in that order. Now, from this table that you're going to generate is what will now give you the opportunity to do your chi-square analysis. Now, how do we count whatever that we have here so that we can get a table in this particular manner? So let's come back here and I'll show you. This is why the basic knowledge in Excel helps a lot. So we're going to come here and say count if. Count. And so here we're going to give 2 conditions. Count if it is CTR carriage and also resistance. All right. So the first condition will use this range. The second condition will use this range. And then the first condition, this is the criteria. The second condition, this is the criteria. And then in that order. So we are going to use count ifs. So it is count ifs. So it's asking us for the criteria one range. Criteria range one. So the criteria range one is here. So you press Control Shift and down arrow, it will highlight the range. And then what is comma? So what is the criteria? The criteria is that if it has something like this, that's one of the criteria. And what's the second criteria? The second criteria range is also waiting for us. Criteria 2 range. The criteria 2 range start from here, then go back again and say if that particular in that particular range, if you find anything that is resistance. So when these two conditions are met, then we should expect it to be counted. But there's something we need to flat fill everything. So because of that, there is some cells that we need to fix them. Now, if I drag it to this, it will now start counting, to now start looking at this in that range. And then, but this cell too, if I don't fix it, the resistance will also shift down to this particular cell here. Instead of P1, it will now come down to P2. So because of that, because P1 is supposed to be fixed, I have to fix that one. So I'll come to P1 here and say function key down and F4 to fix it. So and then tap enter. Then that will give me 7. I move down a little bit. If I now flat fill, it will count the rest. And so now when you come here, look at the formula. We are L L3 to L67. That's the range. That's the first range. And then the criteria is O3. This is O. This is 3. You see that it has shifted. Now, if we had come here, look at the range. It was L2 to L66. This is L2 to L66. Then, and then we see that we also have M2, O2, and then in that order, up to P1. P1 is fixed. And then, so now let's come here. I think there is also something that is wrong that I should have done. Because here we are now looking at L3. So it has also shifted down. The range has shifted down. So the count is not accurate. So it means there are some cells that are supposed to be fixed, especially the ranges. The ranges are supposed to be fixed. So I'm going to come back here, double click. And this is why I like tutorials. We don't just come and just pour the thing there for us, for us to not to understand. So from the beginning, we need to fix those cells too. So I'll also say you press your function key down and F4 to fix it. Then also come here and F4, fix it. The second range too, we need to fix it so that they don't shift. F4, and then this type, F4, function key and F4. So now, the only range that keeps changing, the only range that will have to be changing is this one, O. So this one can shift, this one can shift, this one can shift. The rest are supposed to be fixed. So they will not have any kind of change. So now if I tap enter, so this time around, let's see, it was 6 and 15. Yeah, it's still the same though, but this is the right thing to be done. So now let's come here and the same thing, we have to also use the count if function again. The count ifs, we are here, criteria 1 range. So we come here, shift, and then, and what is the criteria? This time around, and what is the criteria? If it is carriage, okay, I've made a mistake here. Comma, if it is a carriage. All right. Then the second criteria range is from here down. And then what is the criteria? The criteria is if it is susceptible. Now we close it up. Remember the ranges we're supposed to fix. Q1 is supposed to be fixed. So press function key and F4 to fix it. Fix all the ranges so they don't change. Then in that order. Then also fix this one. And then fix this one too as well. And then we are done. So we also do that, then run through, and then now we are done. So if we look at the whole thing, now when we have our source, CTR carriage is resistance 7, susceptible 10. Here, ERT carriage, we have 6 and 11. ECBU clinical, then 15, and then 16. This is how the data, so in your whatever sample sheet you are using or your data sheet you are using, this is what you are going to get. This is how you summarize the table. And now you can now move this table the way you want, and then you can now begin to calculate or do your chi-square analysis on whatsoever. I've already shown you how you can proceed from here. You just need to copy, repeat this, calculate your expected, then calculate your chi-square value, then use your distribution RT to get your what is your chi-square value, sorry, your p-value. Or you can just go ahead and then take your observed range, your expected range, and get your p-value right away. And then there you know. So this is how we're able to summarize. I think this part is the most important, how to be able to summarize the data into a form that you can now be able to use it for your downstream analysis. It's very key. It's very, very key. The videos are long, but please, you need to understand that I'm not doing YouTube content. I'm doing tutorials for you to be able to understand the ethics and why we do the things that we do. So that's it for now. But okay, let me, what is it? Let me check this. So alternates, so you realize that the ground total is what, 65. And then when you check, you can see here, 66 minus the top header. So you see that it's 65. So when you finish and you want to know whether this sampling is okay, you need to check for the totals. And then as you can see, the totals, the grand total is 65, which is here. And so, ladies and gentlemen, this is how we do chi-square. You can also check, and I'll do another video for the goodness of it, and then you'll be able to understand everything. Okay, so thank you. I will see you in another video. Bye-bye.